Okay, let's use these two to explain further the periodic table we are discussing. Let's use these three questions to explain further the periodic table we are discussing. If an element has the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p4, it is a what? A metal. B, an alkaline earth metal. C, S block element. D, a P block element. Please take note. If the last orbital when you write the electronic configuration of a metal of an element is S orbital, the element is said to be a S block element. If the last orbital when you write the electronic orbitals of an atom is p orbital, the atom or the element is said to be p block element. If the last orbital is d orbital, the element is said to be d block element. D blocks elements are called transitional metals. We're going to discuss that. We're going to discuss that. If the last orbital, when you write the electronic orbitals of an atom is f orbital, the element is called f block element. In the periodic table, when you see the full periodic table, the lactinide and actinide series is the F blocks elements. They have their own special features, just like D blocks elements. So now the question, if an element has the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p4, the last orbital here is p orbital, so this element is p block element. Is this element also a metal? What is the last valence electron? That is the last electron, the last energy, the number of electron, the last energy level here is 3 plus 4, sorry, 2 plus 4, which is 6. Such element is not a metal. What is the total number of, this is 6 and 10, 16. So this is not a metal. You know, element with atomic number 16, what it is, right? It's a non-metal. It's not an alkaline earth metal. It's not an S block element. So sulfur is not a metal. So the element is a non-metal. The answer is a P block element, because the last orbital written is P orbital. Here, the electron configuration of two elements with similar chemical properties are represented as. Now take note again. Take note please. If you belongs to the same group, you have similar chemical properties. Any atoms of element that belongs to the same group have similar chemical properties. If they belong to the same group, what does it mean? It means they have the same number of valence electrons. Is it not? I've told you that it is valence electron that determines the group element belongs. Elements in group 1 have 1 valence electrons. Elements in group 2 have 2 valence electrons. All the elements in group 3 have 3 valence electrons, and they have similar chemical behaviors. So the electron configuration of two elements with similar chemical properties are represented as, what is the valence electron here? 2 plus 5, 2 plus 5 is 7. Here, 2 plus 4, that is the valence electron. Number of electrons in the last energy level. What is 2 plus 5 is what? 7. 2 plus 4 is 6. They don't have the same valence electron. So they don't belong to the same group, and therefore they don't have similar chemical properties. For you to have similar chemical properties, you have to belong to the same group. What about here? 2 plus 4 is 6. 2 plus 5 is 7. It's not possible. What about here? Where is the last valence electron here? Third energy level, last electron, last energy level. Number of electrons in last energy level here is 1. Number of electrons in last energy level here is also 1. So what is the valence electron here? 1. What is valence electron here? The last energy level? 1. So they belong to the same group, which is group 1. What is this element? 2 plus 2, 4 plus 6, 10 plus 1, 11. What is the element? Is likely to be sodium. If it's in a neutral state of the element that you write, is a sodium, because sodium has 11 electrons, which is equal to 11 protons. What is the element here? 2 and 1. That is lithium. So this is sodium and lithium. Is that okay? It's not this one. The number of electrons in the last energy level here is 2 and 4, which is 6. This is the last energy level. This one is so the answer is C. The next question is element X has the electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p5. Which of the following statements are correct about the element? Let me call the options. Option A, it has completely filled p orbitals. Is the p orbitals completely filled? No. This is 3p5. The number of electron that p orbital can occupy is 6 electrons. So it's 3p5 we have here is not correct. Another one is it has 5 electrons in each outermost shell. What is the outermost shell here? The last electron, the last energy level, this is the outermost shell. 2 plus 5 is 7. It does not have 5 electrons in the outermost shell. The valence electron, which is the number of electrons in the last energy level, is 7, not 5. So B says it has 5 electrons in the outermost shells. No, it belongs to group 2 on the periodic table. Does it belong to period 2? No, it belongs to period 3 because the last energy level is 3. So it belongs to the period 3. It does not belong to period 2. So what is the next option? It is a halogen. It is a halogen. Now pay attention please. Group 1 elements are known as alkalis. Group 2 are known as alkaline earth metals, just like that. You have boron family, carbon, oxygen family, and the rest of them. Group 7, which we call the halogens. Group 7s are called the halogens, while group 8 are known as inert gases. We are still going to see that some of the features of the halogens. Halogens are group 7. So the answer is a group 7 element. 2 plus 5 is 7, is group 7. So the option is D. It is a halogen because it belongs to group 7. Group 7s are called halogens.